Hi everyone, we have a question of kinematics here today. I hope you all must have heard about the UFO, which is basically an acronym for Unidentified Flying Object. So first of all, without further ado, I would like to start the question first. The question is here as follows. Suppose we have a UFO which is moving with a velocity of say c times eta, where c is obviously the velocity of light and eta is going to be some kind of multiplicative constant. Now suppose that at some particular time instant, the UFO is making some particular angle of theta with respect to some particular observer kept on the ground. Now what will be the velocity of the UFO as measured by the observer who is on the ground? Now first of all, I would like to impose a very simple question as to why this observer will be viewing a velocity which is different from c times eta. Now once again I say here that eta is some kind of multiplicative constant which basically makes the velocity of UFO a very large velocity, and is very quite large as compared to the velocity of standard objects that we view in our day-to-day life. Okay, now the next thing is that how exactly do we view the velocity of a particular object? So the very simple concept here goes that the light from any particular object is basically reflected, and very soon upon reflection the light reaches that particular observer who is viewing the object instantly. So basically we are trying to view an object exactly at the same instant as to where it is located. However, when the object is moving with a very high velocity, suppose a velocity which is comparable to the velocity of light, in that particular case, when the object is moving with an extremely high velocity, there will be some kind of time lag between the two instants when the light reaches that particular observer, and this time lag will result in a different velocity as measured by that observer as respect to the actual velocity of that particular object. So our next step here is to find out what exactly will be the velocity of the UFO which is moving the velocity of c times eta with respect to some observer at the instant when the UFO is making some angle of theta with the vertical line as measured with respect to the observer. Okay, so first of all, we have to make some few assumptions here. Suppose at any particular instant the UFO, as it is given in the problem, is making some particular angle of theta with respect to the observer here, and suppose that the vertical height of the line of action of the UFO is at a small height of h. Obviously h is not mentioned in the question, so our final answer must have some terms which do not contain h. Anyways, the velocity of the UFO is given to us as c times eta, a known constant of eta. Now suppose that we state a particular instant when the first light pulse is reflected from the UFO as the instant of t equals 0. Now as we can see here, the distance of the UFO from the observer at t equal to 0 will be equal to h multiplied by sec theta. So if t equal to 0 is the instant when the light pulse is just reflected from the UFO, the time instant when the first light pulse actually received by the observer will be basically equal to t1, where t1 will be given as h times sec theta divided by c, where obviously c is the velocity of light. It's common sense. However, we have to keep in mind that during this time interval the UFO is not stationary. The UFO is itself moving with the speed of c times eta, where c eta will be a very high speed, as I already mentioned. So suppose that in a very small time of dt, the UFO must have moved by a distance of c eta multiplied by dt. Now once again, from this right angle triangle we can see that the base of the triangle is given by h times tan theta, and the differential of h times tan theta is nothing but h times sec squared theta d theta, which must be equal to the distance moved by the UFO in a very small time of dt. So we equate this value with c eta times dt. Now once again, after a time of dt, when the UFO is at a different location, the new distance of the UFO can be expressed as h times sec theta plus the differential amount of h times sec theta. Now once again, the differential amount of h times sec theta can be expressed as h times sec theta multiplied by tan theta multiplied by d theta. Now suppose that this instant when the UFO is at second location is given as the instant of t is equal to dt. So the particular time instant, suppose say t2, when the second light pulse is basically received by the observer, it can be given as dt plus the amount of light plus the amount of time basically that light takes to travel the new distance, which will be given as h times sec theta plus h times sec theta times tan theta d theta whole divided by the speed of light. Now this simplifies to dt plus h sec theta by c plus h times sec theta tan theta d theta whole by c. Now here comes the most important step. What is basically the time interval of which the two light pulses traveling from the UFO is reaching the observer? That time interval will obviously be equal to t2 minus of t1, which simplifies to dt plus h sec theta tan theta d theta by c. Now basically we have to perform some kind of simplification. This quantity is basically the time lag, or basically the time interval in which the observer at the ground is seeing the UFO at two particular locations. However, we have to keep in mind that in between this time interval, the UFO has actually traveled a distance of how much? The distance must be equal to c times eta multiplied by dt. So this would be the distance as traveled by the UFO, and the time interval in which the observer is viewing this distance is basically equal to t2 minus of t1. So now the only task remaining is to perform a simple simplification. This, as I mentioned, is the time interval of viewing the UFO at two particular locations, which is given as dt plus h times sec theta tan theta d theta divided by c. Now first of all, I would like to perform a simple operation. We know that c eta times dt, it is given to you as h times sec squared theta times d theta. From here we get that dt must be equal to h times sec squared theta d theta whole divided by c times theta. So basically the velocity apparent as measured by the observer, we can say it is equal to h sec squared theta d theta, which is nothing but c times eta times dt, whole divided by the time interval, which is given to you as dt. We can say dt must be equal to h times sec squared theta d theta whole divided by c eta plus h times sec theta times tan theta d theta whole divided by c. And we cancel a few terms here. We can see that h gets cancelled right away, and we can say that d theta will also get cancelled, and we cancel out one sec theta. So the term reduces to sec theta whole divided by sec theta by c eta plus tan theta by c. So this is the basic calculation. I hope you understood the basic concept. The concept here is that since the UFO is moving at a velocity which is extremely high and is compared to the speed of light, the observer will be viewing a velocity which is different from the actual velocity as measured by the crew members of the UFO. Alright? Now if we have to further simplify this answer, we can do that also. So let me just try that once. We can say that the velocity, just rub a few things here. The velocity which is basically viewed by the observer, it can be expressed as, I'll just try to perform the rough work here. It can be expressed as 1 divided by cos theta multiplied by sec theta whole divided by c eta plus sin theta divided by c times cos theta, which simplifies to, I guess, 1 divided by 1 by c eta plus sin theta whole divided by c. So you can leave the answer in this format, which is basically correct. There's no problem in that. I hope you enjoyed a nice time in viewing the concept of this question, and I hope to see you again with various such kind of problems. So long for now. Enjoy our channel. Goodbye.